In schools, we are taught about a man creating three laws that will forever be a part of our understanding of astronomy and physics. But why? Others ask themselves, is it due to the importance it marks on? For example, the transition from geocentrism to heliocentrism. They provide the first quantifiable link between the planets, including Earth. They also represent a period when a significant issue were changing, which is much more significant.
Johannes Kepler was a German astronomer, mathematician, astrologist, and philosopher-writer. Kepler was born on December 27, 1571, and passed on November 15, 1630. Having only lived for about 59 years, Kepler has made quite an impact on how astronomers and physicians view planetary motion. Kepler is mostly known in both the physics and astronomy world. If you've taken both of these classes, then you have most likely heard of Kepler and his discoveries of planetary motion. Fret not if you haven't, for we will get into his three famous laws.
Kepler's first law states that each planet in our solar system orbits around the Sun in an elliptical orbit. The Sun acts as the center point for the rest of the planets to follow in orbit. With this in mind, the planet's distance towards the Sun is always changing based on where it is located on the elliptical orbit. Kepler's second law states that a line that runs from the Sun to whatever planet sweeps out the equal areas in equal increments of time. It also means that the planet will slow down when it moves away from the Sun in its elliptical orbit.
Kepler's third law states the time it takes a planet to complete one orbit around the Sun. It is proportional to the semi-major axis, or the planet average distance from the Sun. However, when the radius of the orbiting planet decreases, the Sun does not only have a longer path than a closer planet, but it also travels slower due to the Sun's gravitational pull on it being weaker. Coming back to the beginning, we're also confused about why these laws are known to be important in making astronomy and physics. But now, coming to the end of this lesson, it is because the efforts of Kepler's explaining the underlying reasons for such motions are no longer accepted. Nonetheless, the actual laws themselves are still considered an accurate description of the motion of any planet.
Coming back to the beginning, we were confused about why these laws are known to be important in marking astronomy and physics. But now, coming to the end of this lesson, it is important the efforts of Kepler's explaining the underlying reasons for such motions are no longer accepted. Nonetheless, the actual laws themselves are still considered an accurate description of the motion of any planet.